Alrighty, so today we're going to hop into Module 5, Lesson 2. This is day 1 of a 3-day lesson. We're going to be solving polynomial equations algebraically. Today we're not going to really solve anything, but we are going to practice our factoring skills because we're going to need those to help us solve algebraically. So up to this point, you have been solving these polynomial equations by graphing them, either on a graphing calculator or on Desmos, okay? So just keep those in mind, or keep that in mind. We're going to be working with algebra again, so you can't just type it in on Desmos anymore. So we're going to start with the first example here. So the first thing you need to do if you're solving a polynomial by factoring is make sure they don't have any GCFs. Okay, so make sure there's nothing in common between the two terms to begin with. So 64 and 49, right off the top of my head, I don't think that they have anything in common because 49 is 7 times 7 or 1 times 49. And that's, I think, pretty much it for 49. 64 could be divided by 8, it could be divided by 2, it could be divided by 4, but 49 cannot. So they don't have anything in common. So what you want to look for here is what's called a difference of two squares. Remember, difference means you're subtracting two things, and squares are something that could be something times itself, okay? So if you're up here, 64 is a perfect square. It is the same thing as 8 times itself, or 8 squared, okay? 49 is also a perfect square, but the y squared also has to be a perfect square with it. So think about it. If y squared, is it a perfect square? It is. It's the same thing as y times y. So it can be rewritten as 7y to the power of 2. So you have successfully identified a difference of two squares, okay? So if you look down here on our notes, we have this pattern that you notice. So you have a squared minus b squared. This would be your a, is the 8. This is your b, the 7y, okay? So what you can write it as, if you have a difference of 2 squared, is this. A plus b times a minus b. So that's exactly what I'm going to do. So you got 8 plus 7y times 8 minus 7y. That's it. That's factoring a difference of squares. You got a question? No, you can go ahead.
Why didn't I keep the square?
Why didn't I not keep the square? So the question was, why didn't I keep the square for y? Because when I do 7y squared, 7 times 7 is 49. Y times y is y squared. It's the same thing. And then when you multiply this all out, you can always check your answer. You could FOIL that out. You'll get the same exact answer. 64 minus 49y squared. It's the same thing. Okay? It just allows us to be able to solve the problem. All right, the next one, I'm looking. I've got 4z squared minus 81. Does 4 and 81 have anything in common? No, they do not. Okay, 81 is literally just 9 times 9. 4 could be divided by 4 and 2. 81 can't be divided by 4 and 2. So they don't have any other greatest common factors. So this is a perfect square. It can be rewritten as 2z squared. 81 is a perfect square. It can be rewritten as 9 squared. So you have the difference of two squareds, okay? So then this has to be rewritten as, give me 1 minute, okay? I'm recording a video, probably like 5 to 7 minutes. Is it something real quick?
I was just going to ask you if I accidentally left my hang gloves in here.
You're welcome to look around if you want. Okay, so sorry about the interruption. I've got... This would be the a, this would be the b, so you can rewrite it as a difference of two squares. So it's 2z plus 9 times 2z minus 9. So we're using that factoring technique, once again, called the difference of squares. I want you to go ahead at this time and pause the video, see if you can figure out that third one. Okay, I'm going to go ahead and go over it. So if you're not pausing the video, I'm going to give the answer. So spoiler alert here. This can be rewritten as v squared. This can be rewritten as 9u squared. It is a difference of squares because it's subtraction. So you can rewrite your answer as v plus 9u times v minus 9u. That's difference of squares. So those would be your answers. So big thing to remember here, factor out the greatest common factor first. You're going to have practice problems. That's going to be like 4u squared minus 16. These both have a 4 in common, so you have to take that out before you do your difference of squares. Even though 4u squared and 16 are both perfect squares, you have to take out the greatest common factor first. Otherwise, you'll get the wrong answer. So you'll factor, it would be something like this. And then you could do the difference of squares for that. You would have to take out that 4 first. Otherwise, you won't get the right answer. Okay? That'll save you a lot of headaches later, so keep that in mind for those types of problems. Okay? For this type of problem that we have down below, you're just going to factor out the greatest common factor that you see. So I've got two different terms here. We're going to look at both of them. The 2 and the 2 are both in common. So I'm going to keep track of my GCF right over here. You got a 2. Now I'm going to look at my v's. I've got v to the 4th here and no v's here. So there's no v's in common. Now I'm looking at my y's. I have y to the 4th here, y to the 4th here. So they're both in common. Okay, when I say factor out a GCF, that means you're going to divide it out. So you've got 2v to the 4th, y to the 4th. You are now going to divide it by that greatest common factor, 2y to the 4th. Okay, you're doing the same thing for the other one. You're dividing it by that greatest common factor, 2y to the 4th. Go ahead, pause the video, see if you can divide that out so you can see if you can simplify that correctly. I'm going to go ahead and do that now. 2's are going to cancel out here. Y to the 4th is going to cancel out here. So you're left with v to the 4th minus over here. 2's cancel out. Y to the 4th's cancel out. So when you have something divided by itself, it's just 1. Okay? You're not done here, though, because you have to take this and rewrite it with that GCF still multiplied to the front of it. So 2y to the 4th times v to the 4th minus 1. Okay? The one thing with this is you need to look, is this a difference of squares? Okay? This is a difference of squares. So write this down. So if you think about it, 1 times itself is 1 squared. So it is a difference of square. So this can be rewritten as v squared. And then it could be rewritten as minus 1 squared. So when you refactor that one out, it's going to become v squared plus 1 times v squared minus 1. Okay? Before you are done factoring this out, you've still got to ask yourself, am I done? Are there any more differences of squares? Okay? Well, v squared plus 1 is not a difference. It's an addition problem. What about v squared minus 1? That is a difference. It's subtraction. So you got to look. Is this a perfect square? It is. It could be rewritten as v squared. 1 can be rewritten as 1 squared. They're both perfect squares. So you have to factor it again. So it's like a problem within a problem. Okay? So then this one is going to be further written to v minus 1 or plus 1 times v minus 1. So all together here, we've got the final answer of 2y to the 4th. We still have that v squared plus 1. And then remember, we had to break down that other term. So we got v plus 1 times v minus 1. So all together, that is going to be your final answer. So a lot of steps there. You just have to make sure everything is completely factored, okay? As long as you follow those steps. Take out the greatest common factor first, and then see, does it have difference of squares in it? Just make sure everything is fully factored. So you might have done one step, but then it's not completely factored, so you won't get full credit. So make sure you really check your problem. Not all of them are going to be that intense, but it's good to see that on the notes just in case, okay? Down here, I think these ones are going to be a breeze for you guys. I really don't think they're going to take you that long at all to do. I'm going to do this first one on the left. I want you to pause the video and do the second one on the right. So what I'm looking here, 30 and 6, they both have a 6 in common, okay? So keep track of that GCF. Both have a 6. Now I'm looking at the u's. They both have at least u squared. Okay. Now I'm looking at the v's. They both have at least 6 v's. And then the x's, well, the other one doesn't have an x, so they can't have a GCF that has an x. So remember, you're dividing that out now. So write that out. You're dividing the greatest common factor. So then here, 30 divided by 6 is 5. U squared divided by u squared cancels out. Those will cancel out, and you're left with that. And then you still have the 6's are going to cancel out. You'll have 2 of the u's cancel out. So you're left with u to the 7th. And then the v's, you'll be left with 2 v's. When it's all said and done, people will forget this step the most. Make sure you take your GCF, write it out in front of whatever you factored. Because you remember, when you factor out, you're really dividing it out. This is just giving us some good practice with factoring before we start solving these on the next lesson. Okay, remember, pause the video and try the next one. I'm going to go ahead and work it out now. So between these two, you have a GCF of 5. U squared. They both have x's, x to the 3rd. And there's no y's that they both have in common. So divide those out. And I'm not going to show as much work for this one, but I am going to write what I get when I divide it out. X would be left. So remember, when you divide, your exponents will subtract. Pause the video, rewind at any time if you need to revisit anything, and let me know if you have any questions.